Hello everyone, good morning. So because of the network connectivity I am unable to um, uh, prepare and upload the videos on time, so please excuse me for that. So the topic for today is like, yeah, Monday and Tuesday we could not conduct the classes because of the network condition, so I am preparing this video. So this is the first part of the chapter and second part is also there. So I'll be uploading two part of this video, and after you go through this video, so you can go with your assignments and submit it to me. Okay, and the assignment is not that tough, it's very easy, so you can easily do it. All right, so the topic is fundamental concepts of geometry. So earlier whatever we have discussed in our previous classes, that was based on arithmetic and algebra, right? So arithmetic is a branch of mathematics which deals with only numbers. I have told you in earlier classes, right? So algebra is basically it is basically dealing with variables, right? But for now, geometry, it deals with points, lines, curves, surface, shapes. Okay, so it is quite interesting. This topic is quite interesting. Geometry is quite interesting part of mathematics. Although algebra and arithmetic seems to be interesting for few people only, but geometry seems to be interesting for everyone because it is where you can draw, where you can place a point, where you just need to find the value of an angle. It's not that tough. Okay, but there is a wider application of this part, right? So what is the fundamental concept of geometry? So what is fundamental? It's like fundamental means like it's basic concept of geometry, right? And geometry, it has derived from the Greek word that is geo and metron. So if you break this word geo and metry made into metron, so geo means earth and metry or metron means to measure or the measurement, right? So if you want to measure the earth or any uh, object that is present on the earth, we use the concept of this geometry. That study is called geometry. Okay, so without delay, let us go into this part, that is point. So point is the first thing that you need to remember. Then after that we move on to line segment, rays, everything will come into play, right? So it is already given in the definitions here in the screen that a point is a geometrical object which marks a position. Okay, so anywhere if you place a point, if I place the point here, that means I'm marking a position at this place, right? Similarly, if I mark another point, let me do it with another color, that is red here. Okay, so you can easily see that blue marking is nearer to my right hand side, but this red mark is little far away from my from blue, right? Blue color dot or blue color point. So that means you can easily know the position, where does it lies, right? So point is a geometrical object which directly gives you a position. Okay, and the another interesting fact about point is that it has no length, it doesn't have any length nor a breadth. Okay, point has no position and point has position, but it has neither a length or a nor a breadth. So you have to keep these things in your mind, because you can just place a point, you cannot make point like this. This cannot be a point, this is a line. Okay, so point is just a dot. We just use the help of dot only, just dot. Everywhere if you place this becomes a point, right? And every dot is different from each other because of its position. All the dots are placed in different positions, so they have their own position, right? So they do not have length and breadth. So point do not have length and breadth. Okay, this is an important point that you need to remember. So how do we mark a point? Okay, how do we mark a point? Let us see. Okay, suppose if I have 3 points here in the book, it is given at dot A, dot B, dot C, right? There are points, point A, not points A, sorry, it has to be point A, this is only one dot, point B, point C. Okay, so if you want to mark these 3 points, so how are we gonna mark this? Let us see. So for this we can just write as, this can be written as point A, this can be written as point B, and this can be written as point C. If I want to mark, how do I mark? I just write point A somewhere on the paper, okay, on the sheet of paper, and another point B nearer to A or somewhere here, and C here. So you cannot just write C, A, or B like this, because BC is just an alphabet, right? So if you want to mark it, if you want to replace it by point, if you want to signify that it's a point, then you need to put the dot before them. So that means you can easily know that that is your points. Okay, so this is the important thing that you need to remember for this portion. Point A, point B, point C. Okay, so next we have is line. So a line is also called a straight line and is a geometrical object which shows a direction. Now you know that earlier what it point do, it marks a position, right? But now it line shows your direction. Okay, line gives you a direction. So that is an important point you need to remember. Okay, so let me write. So yeah, it gives you a direction. Fine. So a line has no thickness. So another point is it has no thickness, and line is, it is infinite or endless. Okay, means that line can extend up to infinity. Okay, it can extend up to infinity on both the side, not only in one side, it can extend up to infinity on both the side. So let us see how does the line look like. Okay, suppose, and there are countless points inside in the line. Okay, if you clearly imagine, or if you think that it is dot, if I place another dot, let me take this way, another dot is there, another dot. Okay, these are the dots, and again if I put another dot, if I make it too compact, then ultimately what you'll form a line. So a line comprises of countless point or infinite points. Okay, so these are the thing. So now let us move on to its symbolical representation. So how do we represent line? Okay, so it can be represented as, okay, so we just draw a straight line this way. Okay, and what I do, I mark an arrow on both the side. So why am marking this arrow? The question arises in your mind, right? So the main reason behind putting an arrow on both the side is that it gives you an idea that the line is extending. Okay, it is extending towards infinity on both the direction. So here you can see the directions. It is going towards my left, it is going towards my right, so it is extending. You cannot exactly measure the distance. What is the total length of this line, you cannot see. Okay, so this is the significance of line. So line goes this way. Suppose this line be L. Okay, line can be named L, just L or M, A, B, C, anything. But sometimes what we do is like we also represent in other way. That is, I'll just mark 2 points here and I write A, B, or sometimes we can also write anything. Sometimes it is given like x, y, p, q, anything. Okay, and even p, q, let me write. Okay, so it can extend up to infinity on both the direction. But okay, AB is there, but extending part, what about extending? Suppose if this be M and N, M and N, this are the extending part. It keeps on going. It does not have any ending point. So this is the reason that we are putting an arrow, right? So this is the graphical representation, or just symbol representation of a line. But how do we write, or how do we symbolically write in mathematics, is that we just do this. See, okay, for AB I want to write this is a line. AB is a line, not a line segment or anything. Okay, it's just a line. So I write A, B is fine, but remember this thing, I put the bar above AB and put an arrow. So this signifies that it is a line A, B. It is understood. Okay. Similarly, for B, this second part, X and Y, I write X, Y, and again put an arrow. This is called line X, Y. Similarly, for PQ, I write PQ this way. This becomes your line PQ. Fine. So this is all about line. Okay. And line has no ending point. I told you that it is infinite or endless. Okay. So it has no end point. So another point you can mention here is like it has no end point. And the reason why it is not having any end point is that because it is infinite or endless. Okay, it keeps on extending, so it has no end point. If it has end point, then it will end at some point, right? But it doesn't end. So this is all about line. So next we move on to another part, that is, in the book it is given curve, but after that we after line we move on to line segment, then we will come to curve later on. Okay, because you can easily relate how does a line and line segment differs. Okay, so line segment. So the definition for line segment is a part of a line is also is known as a line segment. Okay, or a portion of a line segment. We know that a line is drawn in this way. Right, this is a line. It is extending on both the directions, or else I'll just do this. Okay, it keeps on going here. It's even going here, right? So this is a line. Okay, it's extending. Okay, but this is a line, and I want to find a line segment here. I want to take out a line segment. Okay, so how do we take? Just a few portion of it. So if I cut this part and this part, if I want to take this out, suppose this be A and B. So I have cut down this part, right? A and B. So I'll just take A and B right this way. But you know that line is extending still. It's fine. We are just taking out this point, right? So this becomes A and B. Since you have cut this, so there is no any arrow because it will not extend. This AB cannot be extended. Only this can be extended. This cannot be extended. So this has ending point, right? So this becomes your line segment. So the definition itself says a part of a line is known as line segment. So if you take this AB and put it here, it will fit here, right? Because this is a part of this line. So that's why line segment has two end points. The important point that you remember here is it has two end points. And what are the end points here above? A and B. A and B are the end points here in the figure, right? So how do we denote line or represent symbolically? Okay, Here is C. So if I want to write symbolically or represent this line segment, I write A, B. Okay, AB is the endpoint. I'll write AB, but I just put the bar. There is no any arrow now, because if you put the arrow, that becomes your line. If you just put a bar only, that becomes your line segment. That is understood that it is a line segment. It has definite length. And the important another point that you can mention is it has definite length. Okay, that means you can measure the length, whereas in line you cannot measure the length because it is endless, but here you can measure the length. All right, so this is the thing. So even if it's xy, you'll just write, suppose it is xy. For now, let us suppose this is x and y, right? I write x, y, and I write here x, y, and just a bar. So this is understood that line segment x, y. Okay, that is the thing. So now another part or the interesting part is ray. So ray, you can easily try to relate both the things that we have discussed, line and line segment. So what I have realized is that in line segment, what we have found, line we have found like it is like this. Okay, both the ends are having no end, any end point. Okay, there is no any end point, but in line segment there is end point, and we connect it by line. So this becomes your line segment, this becomes your line, right? So ray. So if you combine these two, okay, if I take one part of it, suppose if I take a left hand part of the line segment and right hand part of a line, if you combine these two, how does it look like? Tell me. It may look something like this. On one side it will be line, okay, it goes on the point it will be line segments dot. Okay, that means here we have end point, here we do not have end point. So if you combine these two, only one side will be end point, another side it will not have any end points. So here we can easily see that one side of this line is ended, but this side it is on the right hand side it is not ended, right? So that means it is a ray. So how does a ray look like? You can take an example from the ray of light. We see that ray of light, right? Suppose I have a torchlight. Okay, let me this is a torchlight, suppose, right? And there is a source of light coming out from this part, okay, and there is light coming out, but you never know where does this ray of light ends, and we say it called a ray of light, but we can easily relate that this is the end point. Let me mark it with another color, this red marking. So this is the end point for now, and this is the endless point. So it keeps on going. This is a light, okay, you never know the end part of it, right? So it keeps on going. That's why we say a ray of light. Okay, so this is the end point here. The torchlight is the end point, and the light, the beam of light where it ends, that is the endless point. So that is a ray. Simple example of a ray. So ray can be represented as, suppose this be A and this be B. We just put a dot just to signify only, but there is no any endpoint. Okay, remember that. So if I want to write a ray in the graphically, symbolically, we write A, B, bar, and one side arrow, because it's a ray, and we understand that that is a ray A, B. Suppose this be PQ, then we write PQ on one side arrow, this is understood that this is ray p q. Okay, so this is the symbolical representation of ray. Okay, so next we have, let's see, okay, curve. So curve, you are already familiar with curve, right? Because in art classes we have drawn many shapes, figures, everything, right? All the things are not in a straight line. Okay, sometimes it's little curve, it's distorted. Those are all applications of curve, not exactly curve but applications. Okay, so a line which is not straight is called a curve. Okay, any line which is not straight at all, it is called a curve. So how does a curved line look like? It's already given in the figure in the book. Let me draw it. Okay, it's given like this. You can see it is not a straight line. I can draw another line. This is given, right? And there are alphabets where you can easily say this is a curve, just like C. Okay, and if you write small letter M, and O. Okay, there's a O, then S, R. These are all curves because this is not a straight line. Okay, so line which is not straight is called a curve. Okay, so now we have another interesting part, that is plane. So what is meant by plane? A plane is a flat surface which has length and breadth in it. Means that whatever we have studied till now, line segment, ray, curve, it has just a length. It does not have any breadth. That means it does not have any thickness or another dimension into it. But here in plane we have length and breadth. Or else we can say that if you combine point together, you form a line. Point, I'll just write here. If you combine point, the combination of point give rise to lines and line segments. Okay, but all the combinations of line segment give rise to planes. Okay, and another topic, another thing is that if you combine planes, then it gives rise to space. Okay, we'll come into that topic later on. So remember these things, that if you the combination of point gives rise to lines or line segments, curves. Okay, but again, if you combine these line segment, curves together, you form a plane. Then ultimately if you combine planes, you form a space. Okay, so let us see how does it forms. Okay, so this is an interesting part. And okay, a plane is a flat surface which has length and breadth. Okay, it has length and breadth. Suppose if I take an example of one length, if I draw this way, okay, this is also a line or a line segment for me, right? If I draw another line this way, line segment, okay, if I draw another line segment here, and if I draw another line segment here, so what I get, this can be anything. Okay, this can be tabletop, this can be sheet of paper. Okay, if you keep it upright, it can be a wall, surface of the wall surface. It can be tiles which you keep on the floor. Okay, tiles or floor, anything. Okay, it becomes a surface. Ultimately it becomes a surface. So how does surface is formed is like, because of length on this part, or any part. Okay, the longest part should be length, and this be suppose breadth for me. Okay, so length and breadth gives rise to planes. Okay, if you combine all the length and breadth, lines, you form a plane. And the length and breadth of a planes are infinite. Okay, so length and breadth is not fixed. So in mathematics what you do is like, while solving questions we just say that length is this centimeter and breadth is suppose that centimeter. That is just for our time sake, but it does not have any fixed length, so it can rise up to infinity. So length and breadth can extend up to infinity, right? And the thing is like, all the point lines or line segment curves, okay, rays, those all lie on a plane. Okay, those all lie on a plane. Why and how? See, if you see this board, whatever I'm using it right now, this is also a plane for me. Okay, this screen, this is a plane for me, right? But I'm drawing dot, I'm making line, I'm making a line, sorry, I'm making line segment, and I'm making a line here, I'm making a ray. So I can draw everything in this plane. Okay, the plane, for me this is a paper, so I can draw anything on this plane paper. So plane comprises of all point, dot, line segment, curves, okay, rays, everything. Okay, so it's that. So now next we have interesting part, that is space. So all objects such as point, lines, planes and solid belong to a geometrical object called space. See now, it has got length, breadth and height. The statement itself says it has got length, breadth and height. So in plane, what did we do? We just had length and breadth, but now there is also a height. So that's why it becomes a space. So let us see how do we form a space. Um, Let me draw another earlier drawing. Okay, it was like this, isn't it? It was like this, or else I'll draw a little smaller. Okay, it was like this. So this was a plane for me in a previous session. Okay, suppose this be length for me, this part be length, this, if this is length, this is also length, no doubt. This is breadth, means this is also a breadth, until and unless it is a rectangle. Okay, this is my breadth. Okay, this is my length and breadth. Suppose if I have another plane, okay, if I have another plane like this, okay, this is another plane. So if I combine these two, if I add these two, so how does it look like, tell me? So I need to combine it anyhow, so I need to arrange in such a way that it fits, right? So I bring this part here. I combine these two part here now. See, this is second part and this is my first part. So if I combine like this, ultimately if I arrange again, if I arrange another plane also and join it here, just like we build, we make projects. Okay, we do make project, right? For science and all, we combine every planes together to make a box or something. So if I another join it, another again join it, another, this four part. Okay, again if I join it another, I have surrounded every part now. So on top of that also I need to make it, right? So on top of that I make it a lead to cover it. So the whatever what we have found inside now, is there anything? Nothing. So that becomes a space, so where you can freely move, where you can just keep your objects. So here this part is called a height. Okay, this part is called your height. So space contains everything now. So plane contains like dot, line segment, line, curves, right? rays. But here space contain everything along with plane. It contains plane also. You can also put a sheet of paper inside this plane, sorry, space, right? Isn't it? If you imagine, if you think of a box, inside a box you can put anything, right? So that is there. Okay, so this is the interesting part of the space. So the example for space can be like your classroom with the wall surrounded and there's a rooftop and floor. We all are inside, we are also a part of that space. If even if you take an example of a chalk is also a matter which belong to that space. As I have already told you in physics classes for the first topic, that is, I think, yeah, matter. Okay, so matter is something that occupies space and have mass, right? So anything, even a chalk dust is a matter in the classroom because that chalk dust occupies some space in the classroom. Okay, anything. So now we have another topic, that is figure. Okay, so basically there are two types of figure. One is open figure, another is closed figure. So how does the open figure and closed figure look like? It's already there in the book, but I will mention it here, right? So open figure means the figure, let me go with closed figure first. The figure where the starting and the end point meets. Suppose this is my point from where a figure gonna start. So if I am drawing something like so it meets at the same point. Okay, if I draw another figure, right, it is meeting at the same point. There is no any loop. If you zoom it, you cannot see any loop. There is no any loop. Okay, it's no any loop. There should not be any loop. This is a closed figure. Okay, even if I draw this, okay, square, box, these are all closed figures because there is no any loopholes are not there. But whereas in case of open figure, how does it look like? If you start from this point, it ends here, right? But there is a loop. I'll show you where's the loopholes. Okay, even if I draw a square, but it is incomplete square. For triangle also, even for curves also. Okay, so I'll show you the loops. So where are the loops? So here the red markings are all loops. That means it is not meeting yeah, at the same point where it started. Okay, so starting and the ending point should meet at the ending line should meet at the same point. Okay, so if they meet, okay, if the beginning, the figure where beginning and ends, where that the figure that begins and ends at the same point, that is called a closed figure. And the figure which does not have any criteria to that, or we can just say it, the ending and the beginning does not meet at the same point, that becomes a open figure. Okay, so now we have interior and exterior of a closed figure. Okay, this is also quite simple. For this we'll take an example. I forgot to draw. I'll draw it here right now. Let me take time for now. Let me draw it. Okay, suppose I have one figure. Okay, I have one figure. Let me draw it here and place a point. Suppose this is A, X, P. Outside we have M, N, Q, R, T. On the line itself, Z, we have here point B. Okay, so the very basic definition of interior and exterior is that for interior, okay, for interior, the part of a plane, the part of the plane enclosed by the closed figure is called the interior of the closed figure. Means that a plane or the part of plane enclosed by that closed figure. Okay, so whatever is the part or whatever is the point lying inside the figure, that is all interior of the closed figure. Okay, whereas the part of plane outside the closed figure is called exterior of the closed figure. So whatever is the part outside the figure, that is all exterior. So in my case, I can take an example like this is my interior. Let me do it for interior with which color? Okay, let me do it with light green. So this is my interior, everything. Okay, this is my interior, and my exterior is, these are all my exterior, outside part. Okay, so let me write what are the if the question says like mention the point which lies interior in the which lies to the interior, or yeah, which lies to the interior of the closed figure, it may say like that, and you need to mention what are the points that lies to the interior of the closed figure, right? So interior of the closed figure. So what are the points that lies to the interior of the closed figure? Here we have A, P and X, not Z and B, because Z and B lie on the figure itself. Okay, so the interior of the closed figure is dot A, dot X, dot P, right? Similarly, interior of the exterior of the closed figure, right? So that is what are the point that lies outside the plane or the figure. Those are what? Those are this T, N, M, R, Q. Point T, point N, point M, point Q, point R. So these are the points which lies to the exterior of the closed figure, right? And sometimes the question may be like mention the point which lies on the closed figure, which lies on the closed figure. So what are the point that lies on the closed figure itself? Those are this point Z, point B. All right, so this is a quite good concept and you need to know it, right? Later we have boundary. Okay, so boundary, you know it. Where do we put the boundary? To surround ourselves, right? So we have boundary of walls. We have this wall is also a boundary for our homes, because if we don't have boundary, there is a chances that we might get cold, the rainwater might seep in. Okay, so anything can happen, right? But if we put a boundary, we are safe inside. So there are different types of boundaries, but for now we have curvilinear and linear boundaries. Okay, and you know what is curve and what is what is line, right? So boundaries are of two types, that is curvilinear and linear boundaries. So what is a curvilinear boundaries? A figure that is bounded by curves. So that is bounded by curves, because itself it says that curvilinear, curve word is there. So that means it is bounded by curves. Whereas in linear boundaries, it is bounded by straight lines or line segments, because it need to have a fixed length, right? That's why it is called a line segment, not line. So curvilinear boundaries, it is bounded by curves. Linear boundary, it is bounded by line segment. Understood, right? So now, how does a curvilinear boundary look like, and how does a linear boundary look like? Let us see. Suppose I have, if I want to represent a pond in a garden, I just do like this, isn't it? That is a curvilinear boundary. Okay, even in maps also, you have seen India map, any map of the world, right? So what I do is like I make like this. See, so if you zoom it, you will see there is no any straight line. These are all curves. These are all curves. Okay, these are all curves. Okay, these are all curves. So now you need to find which is curved boundary and which is a linear boundary. So how does a linear boundary look like, right? Any other example that you can give to the curvilinear boundary is like, you can make a circle. Even circle is a boundary, but it is not a straight line, it is a curve, right? So here we can easily see that these are all curved. There is no any straight line. Okay, so this is also a curvilinear boundary. Any other example that you can give is like number 8. That is also a boundary, but that is a curvilinear boundary. It's not a straight boundary or a linear boundary, right? So next we have a linear boundary. So how does a linear boundary look like? So linear boundaries are those boundaries which are bounded by straight line segment, right? It has to be straight. It should not be curved. So how does it look like? If I draw a triangle, okay, that becomes a linear boundary, because if you see, it's a line segment. It's a line segment here as well. It's a line segment. That means it's a straight line. It is not a curved line, right? So now another example that you can give is like, you can make any shapes. Okay, this becomes your linear boundary. Triangles or any architectural designs, especially having straight line, these are all linear boundaries. Okay, so this is the thing that you need to remember. All right. Next we have, okay, so this ends your uh, first video based on fundamental concept of geometry. We'll be uploading another video soon along with this, right? So kindly go through this, and if you have any doubt you can ask me, and this topic is quite interesting. You can go through your book, okay, and you need to solve your exercises. Okay, all the questions from exercise, the question is not that tough. You just need to write only this time. So it's like question number 1 to 12, everything you have to do it. And another extra question has been given, so I'll send it to you by evening. So kindly check your class groups. So there we have already sent you the mathematics assignment. So extra question is mentioned there, you need to do that. Okay, okay everyone, stay safe, see you soon.